yeah, I'm just going to quickly write the whole thing once again so that I'm able to explain it better. X1, X2, 7 is my first row, Y1, Y2 and Y3, no values in the second row, Z1 and then 8 and 3. Now, this is equal to the values that I'm going to figure out on the go. What I know already is 7, I know 8 and I know 3. That's all that I know. What very important, what the condition they have given is sum of all 3 elements along any row, column or diagonal is equal. Okay. For me, obviously, if you are if you form linear equations and solve them simultaneously, you're going to get your answer. That's one way to do it. I think that's a slightly time-consuming way to do it. I think you should treat this question more like a puzzle of a logic section rather than a quant or a matrix question. Okay, we just need to, ultimately it is just a a question of fitting the values properly so that the sum is equal. After that, we are going to apply the concept of determinant and find the value. Okay, so for the final step, we will come back to the quant mode. Right now, we can be in the logic mode. Let's see how we take this as a puzzle. Okay, they say every row, every column, every diagonal adds up to be the same number. Okay. So how do we really start? For example, have a look at this guy. Let me just change the color of my pen. It should help you understand it better. If you have a look at this diagonal and have a look at this row, we know that the column, we know that the totals are going to be same, right? The bottom row currently has a Z1, a 8 and a 3, which means it has a Z1 and an 11. The diagonal has also a Z1, a Y2 and a 7, which means, do you understand that Z1 is common for both of them? So let's just ignore Z1. So you know that the other 2 elements also have to add up to same if the total has to be same, correct? Which means both of these have to give us a total, leaving Z1, they have to give us a total of 11. Correct? The other 2 guys are 8 and 3. They are adding up to 11, which means 7 something should also add up to 11. So that 11 plus Z1 and 11 plus Z1 like this and like this will give us the same answer. I hope you get that. Which means we already know this guy has 7 here, which means I can confidently say that this guy is 4. Only 7 plus 4 is going to give me 11, correct? I see, we've not figured out the value of Z1 here. Z1 was common, we eliminated it. But because of that, we could figure out the value of Y2. Okay, I hope you understand this. So the trick is to find one common variable which is common across 2, either a row or a column, or a row or a diagonal, or a column or a diagonal, and get your answers. Let's see, maybe any other common element. Let's take Y3 as common. Okay, if I take Y3 as common, and then if I see, let me just change the color. Let's say if I take this particular column. Okay, this column is what? 10 and a Y3. Then this row should also be 10 and a Y3 because Y3 is common there. So if the last column is 10 and a Y3, the second row is also, or rather should be a 10 and a Y3. And if that second row has to be 10 and a Y3, this guy is nothing but 6. Only then it can be a 10 and a Y3, right? So we have in a way figured out Y1. Correct. So I hope you get the drift. You just need to understand, or rather keep picking out these common variables across 2 things and get your answers. That's how simple it is. Okay, fine. Now let's use Z1 as being common. So if Z1 is common, let's take the last row. If Z1 is common, the last row gives us 8 plus 3, 11 and a Z1. The first column should also give us a 11 and a Z1. Correct. So if this is giving me, last row is giving me 11 and a Z1. First column should also give me 11 and Z1, which means my first row, first element is nothing but 5. I hope you are understanding this. Now, very, very important, you should see that we have figured out all 3 elements of the diagonal. Okay, 5, 4 and 3, which means now we know what is the total, and the total is same for everybody. So 5 plus 4, 9 plus 3, 12. So basically all rows, all columns, all diagonals need to add up to 12, and now we are sorted. So if this guy is 12, 5 plus 6 is 11. Therefore, the last element in the first column has to be 1. Okay, 8 plus 4 is 12 in the second column, which means this guy has to be 0, and 6 plus 4 is 10, which means this guy has to be 2. And that's about it. We figured everything out. So our logic puzzle is over. Let's go to the quant mode now. Now we just need to find a very simple determinant value. So let's find the determinant value of this guy. Determinant value is going to be 5 times 4 into 3, 12 minus 16. Second element is fortunately 0, so we don't have to bother. Plus 7 times, let's go to the direct third element. 6 into 8 is 48. 48 minus 4 is 44, right? So 12 minus 6 is minus 4, and into 5 minus 20, plus 7 into 44. 7 into 40 is 280. 7 into 4, 28. 280 and 28 is 308, and 308 minus 20 is nothing but 288. So that is going to be our answer for this particular question.